Good afternoon, ladies and gentlemen. It is 3:05, and finally, for the first time in what feels like for fucking ever, I get to do some more coding. It feels like I keep getting stun locked and like, oh man, I have this other obligation to attend to, this other thing that I said that I would do. I really got to stop promising to do things without thinking ahead of time. But you know what? It's fine. It's fine. So today we're going to be starting chapter 18, Inheritance, but real quick before we do that, we have like 10 minutes of size of objects to get through, which I don't think will be too long because I'm pretty sure that it's just going to. I get the sense it's going to literally be like size of object. We'll find out if I'm wrong about that, but there's only 10 minutes of that section in the video, so we're gonna go ahead and we're gonna watch that first, and after that it's gonna be coding for probably around 2.5, 3 hours, depending on how long things go, how well it goes, if there's anything crazy going on. Inheritance looks like it should be a 2.5 hour section. So that should be the rest of the week for us, given how much stuff there is. So we're going to be doing size of objects in chapter 17 first, and then it'll be introduction to inheritance, first try on inheritance. I don't know what that means. Protected members, base class access specifiers. So we're gonna try and get a little bit of we're gonna get started on inheritance today is the objective. And we'll probably end up finishing it or doing more of it like later over the course of the rest of the week with any luck. We'll be and then after that with any luck next week will be polymorphism the whole week. It should be 5 hours of polymorphism. So yeah, without any further ado, let's get over to here. Let's see, absolutely no scuff here. Put that up there. Boom. We're also going to go ahead and just expand this for now for the time being, while we watch it. So we'll go like so, and then once we get to the VS Code portion, we'll minimize it again. I think I'm going to start doing that. All right, let's go.
In this lecture, we're going to learn about sizes of class objects and try to think about it. What are we going to
Hell
see
yeah,
if we
inheritance.
try to print the
Yeah,
size
we'll get to
of
that in
our
like a few
class here
minutes. That should
called
be the
member?
majority of it.
Inside we have two member
Unfortunately, I have this
variables which
last
are of
section to do
int type,
of
and we have
17.
a member variable which is of std string type. What do you think we'll see when we print the size of this wrapper object here? Try to think about it. So what C++ does, it's going to only account for the size of your member variables. So it's going to add the sizes of these guys in memory. So we know an int is going to take 4 bytes in memory. So we're going to have 8 bytes for these two ints. And we're going to have an unspecified amount of memory for a string because a string is internally implemented as a class and it stores its data as const char pointers. So we have really a pointer, and the size of an object doesn't really account for things you are referring to using pointers. It may count the size of the pointer itself, but it's not going to count what is pointed to. And in the case of string, for example, we really want to know the range of things that we are pointing to. So we're not going to have correct information with std string here. But in general, the size of an object is going to be the sum of the sizes of its member variables. The functions are not going to be counted then. The functions are just helper functions that live somewhere in memory, but they're not going to be accounted for in the size of your object. Another reason you might think functions are not accounted for in the size of the object is that really functions are affiliated with the class itself.
Different types have different sizes. Some funny objects can change sizes, such as vectors. Oh boy, that'll be fun to figure out. How goes it? Hope you're winning. Been watching your Resident Evil vids. Oh yeah, I've been winning. I feel like I've been winning a lot. I've been a little bit annoyed that I haven't been able to do the C++ stuff recently, because I've been having other obligations that I keep forgetting about, and It's just a go figure that as soon as I try to make a waiting room in advance for one of them, it's like, oh yeah, actually I got to delay it multiple times. I mean, fundamentally though, what he's saying here kind of makes sense. Like an object is the size of all of its stuff put together, and like with something like the string where you don't actually know it until like compile time, I guess. It kind of makes sense. That's kind of my understanding of it so far. Is that it'll like the size of this thing is determined once you've created it, but it's not actually specified until that point because you have to like it's like a pointer. Oh god, dude, I'm like my brain. It actually sometimes isn't. Objects with 16 bytes of sizes are much more likely than 15 bytes of size. CPUs be like that. Really? Is that just because multiples of 2 are easier to deal with or something?
Functions are not affiliated with class objects. The class is going to be the blueprint from which we're going to generate thousands of objects if we want, but the functions or the methods are going to be associated to the blueprint itself. So it really wouldn't make sense to associate the size of those functions in memory to class objects. Now that you have
Huh.
this idea, let's head over to Visual Studio Code and play with this a little more. Okay, we have said that the size is mostly going to be the sum of the sizes for the member variables, but this is not always correct because of a phenomenon we called boundary alignment.
Like a 4-byte object and a 2-byte object inside a class will probably be 8 bytes and not 6. I don't know why. Probably has something to do with cache efficiency and shit. You could always check with size of. That's true. That makes sense.
Boundary alignment is a thing most compilers do when they have member variables of different types. And member variables that have the size of 4 bytes in memory are going to be stored at memory locations that are multiples of 4. And because of this phenomenon, we might have gaps between our memory if we have variables, for example, that are of 2 bytes in memory and 4 bytes in memory. And we're going to have gaps inside, and the size of the object is going to be slightly off the sum we might do for the sizes of our object. I realize this may be confusing. We're going to head over to Visual Studio Code and we're going to see a few examples. Okay, here we are in our working folder. The current project is size of class objects. We're going to grab our template files pretty quick and we're going to put them in place. And we're going to open our project in Visual Studio Code by dragging and dropping here. We have our main CPP file. We can close the left sidebar and we can clean the main function here. We're going to set up.
Okay, for some reason my template project isn't showing all the stuff that it should. A little bit annoying. File, open folder. Surely it will let me see the things that I need to see. Do I just need to open it in the File Explorer? Is that why I can't see the CPP files? That is why I can't see the CPP files. That's very annoying. All right. This thing should be pretty small. So there's a chance we can use it again. Folder project 47 in the frickin'. All right. So we go file, open folder, project 47. Boom. That is not what I wanted to open. All right. Finally. Do all this stuff. I'm gonna need to make a bunch of these.
A simple class. Let's call this.
Damn, he explains it 100
dog.
times
Why
better than
not?
me
We have
instantly
been
after.
using dog, so let's use this again. We're going to put our closing semicolon. We're going to put.
Today you learn about inheritance. Tomorrow your parents mysteriously die.
A constructor, and we're going to say dog, and we're going to use the default, and we're going to put in a private section, and in here we're going to put in a size t and say this is the leg count of the dog. Why not? Let's say we are modeling this. Okay, so now we have our dog class in place, we can create objects of this dog class. We're going to say dog1. And if we do this, we are interested in knowing the size of our dog class here. So we are going to say stdcout size of dog, can save that, and fingers crossed we're going to see the size of our dog object here, and try to guess what we're going to get. In the slides we have seen that the size is mostly going to be the sum of the size of the member variables. And let's print the size of size t here, because size t is our only member variable, so I think it's going to be helpful to see its size printed out. So we're going to have some context if we do that. We're going to say size of size t, and we're going to save that, and we're going to build this program. Let's do that. We're going to pass this through GCC. You see the build is good, and we're going to bring up a terminal and run this. See what happens.
Okay, hold on. Ah, new terminal. Oh, holy shit. Programming lingo gets real scary. Some of the stuff I wrote about killing parents and leaving the children as orphans still horrifies me. You know, it's funny, when I mentioned that I was going to be learning about inheritance, my dad was like, "Oh man, I thought you were getting ready to knock us off, you know, and start trying to come after some money." And I'm like, "No, you're still worth more alive than dead." Let's see. So we have size of dog, size. I should probably make this look correct, so I don't confuse myself. Size of size t. If size of hog is less than 13, return -1. Oh no. The size of my hog. It's less than 13. What do I do? Gotta... Oh boy. Okay. Working with a foot long. It's like a $5 foot long. Okay, anyways. Leg count, dog default. So, in theory... fuck, do I remember what the size of size t was? I remember size t was the same as unsigned int. So it should still be... should be 4? Is my guess? Or am I misremembering that? Is that an inside joke? I think the idea is that if your hog is your hog is your Johnson, your junk, your dick, as it were. And then I assume 13 is inches, though I suppose it could also be centimeters. Either one would kind of be funny, I guess. All right. What a dumb joke. That's hilarious. Yeah, yeah.
Happens. Okay, we see size of size t is 8, and
it's 8. Oh, I'm an idiot, dude. How could I forget that? Oh, damn it. Oh, wait, what did I fuck up? I fucked something up. Int main, is it? It's not this. It's this, right? That must be. Terminal. Man, it's like I forget one semicolon. The best jokes are the most simple. I won't necessarily disagree, but I like a convoluted joke now and then. Size T is going to be your CPU's architecture, so 64 bits. Oh, okay. Well, it's 8 for me as well, so. Just look at Rag, for example. Oh, shush you, Redbird. Asshole.
the size of our dog object is 8. And this is really cool because we see that the size of our class object is really the size of our member variables that we have in here.
So if I created another member variable
and really
oh
show
boy,
you
yeah, let's see this.
So we're going to have arm count, okay? So we are just messing with us to learn. I don't aim for this class here to make some sense practically. We just want to see how the member variables affect the size of our class object. Now we have two member variables n. We're going to try and build. We're going to use GCC to do that. And we're going to clear and run rooster. Now you see that size of dog is 16. And this is really proving that the size of an object is only accounting for the sizes of the member variables.
Okay, I want to try adding a short. Just call it, I don't know, brain count. Short is like the short ints, right? I think, if I'm not mistaken. Should be a really small, a small amount. Okay, so that increases it to 24. Short is half an int. But that increases my total to 24. So let me change it. Kind of want to see, make sure that I'm understanding this correctly. All right, so this is a lie, but this is actually supposed to be short. I didn't edit the text, but it is showing the correct amount for a short. So it is only 2 for a short, but adding another one, adding a short to after we had 2 size t's made our total object size 24. That's kind of interesting. That it seems like it added another 8 for reasons that I don't quite understand. Try adding short as the first member. Does that change things? I think that might be change the size to 20, but I'm not sure. It did not. At least it doesn't seem like it. That's interesting, though. This stuff is arbitrary on our end. I mean, yeah, but it's still interesting to learn about. I still think it's... I'm kind of curious as to why it is. I mean, I think this might have to do with the boundary thing that he was talking about before, and maybe he'll explain it again. But yes, changing order might change size. Wonder if I change this one to a short as well. If I do it like this. So if I make the first 2 shorts, and then only one of them is a size T, then it turns the total size to 16. I believe our CPU runs much more efficiently if we separate things into blocks, so usually 4 bytes. 8 bytes actually, as our CPU is 64 bits, 8 bytes. I mean, that makes sense to me. I could see how that would be the reason. Because now both of these shorts fit into one 8-byte block, right? Is kind of the... Whereas before I had two 8-byte blocks, and then there was another one that was just like, okay, well, fuck it, we'll throw another 8-byte block at it, instead of just assigning two bytes to it. This is kind of cool. All right, but we're gonna make this a size T again, so that we can make our stuff look like his. Size T. Is there a reason that it's red? Our compiler calculates for us how wide a type should be. This is important for game dev server stuff. I mean, that's good to know. It's good to understand why something might be too large or too small. I don't know if too small would really be a thing, but particularly why something might be too large in some scenario. But yeah, okay. Well, we'll just leave the brain count in there.
It's not going to count the functions that we have here. So if, for example, we had a function that says printful, and we have another one that says do something, this is not going to change the size of our object, because functions aren't accounted for in the size of our object here.
Interesting.
So let's build and really show you this. The build is good. We can clear and run rooster. we see that we have the same sizes. The size of dog is 16. The size of size t is 8. We can even use object names here. For example, we are using the class itself, but we can use dog1 here, and we're going to get the same information. Let's build, and we're going to clear and run rooster, and you see that we have the same size. So if we change this thing to put in a pointer, we're going to see something else. Let's put in an int pointer, and let's say ph, like we have been.
Okay, hold on. I want to get the function that he put in there in, because I guess it hasn't really been mentioned in the course so far, probably because it doesn't really need to be, at least not yet. But like functions not being part of sizes, yeah, I'll just write the whole thing. The fact that the functions aren't accounted for when it comes to size is something that I think is it's interesting for reasons that, like, it never really occurred to me that it wouldn't have a size. Like, it feels like the kind of thing that because it's not like, oh, I'm creating a variable, and storing a variable. It's an instruction, which I don't know exactly how that's accounted for in terms of memory for for the purpose of size, because it's not. You're not like I mean, I guess you have to create the function first, but then it's called upon, like, if in theory, multiple times. But I think it's I think it's kind of. I'm curious how it does get accounted for, because if it's not accounted for in size, it's got to be accounted for in like processing time or something, right? Surely.
The size of our object, because functions aren't accounted for in the size of our object here. So let's build and really show you this. If the build is good, we can clear and run rooster. We see that we have the same sizes. The size of dog is 16. The size of size t is 8. We can even use object names here. For example, we are using the class itself, but we can use dog1 here, and we're going to get the same information. Let's build, and we're going to clear and run rooster, and you see that we have the same size. So if we change this thing to put in a pointer, we're going to see something else. Let's put in an int pointer, and let's say ph, like we have been doing all along, and see what we get. And we know that the size of a pointer on my system, let's print that out so that we have no doubt. Let's, for example, say size of int pointer is going to be size of int pointer. Okay, let's build. We're going to pass this through GCC, and the build is going to be good. We can clear and run rooster. We're going to see that we have 24 because we have two member variables that are going to be 8 bytes in memory of size t. They are of type size t, and we have a pointer which is going to have a size of 8 in memory. But we don't care what this pointer is pointing to. If, for example, this pointer is pointing to something really large, we don't care. We're just going to account for the int pointer here. And this is really phenomenal, because if, for example, we try to set up an std string object, and by now you should know that std string itself is implemented as a class in C++. So it's really a class, and we can print its size. So let's set up a string object here. We're going to say std string, and we're going to say name, and we're going to initialize this with hello world. Okay, we're going to see something really strange here. So if we print the size of name here, we're going to say size of name, and we're going to print that. Let's see what we get. We're going to run, and we're going to see the build is good, and can clear and run rooster. We're going to see that size of name is 32. Let's change the text inside our string and see that we change accordingly, because this can really be confusing.
Why is this red? Oh, that. Was reminded of a dev log that talks about bit crunching. The devs needed to push certain values, but even the smallest data type wasted bits, so they used wasted bits to transmit other data too. How do you do that? That sounds insane. That sounds like the kind of thing that you come up with and win prizes for.
Say I am the king of the universe. Why not? And we're going to build again. Let's see what we get. Fingers crossed. This is going to blow your mind. You see, we have the same size for name, even if we are changing the text in here. So what is really happening, the string is storing our text here as a const car pointer. And what we have is a pointer inside. And what we probably have inside is a member variable, which is a pointer like we have here. So what we will be accounting for in the string class is the size of the pointer, but it's not the size of what is pointed to. Okay, so the car pointer may be pointing to thousands of characters in memory, but as long as the compiler is concerned, it's just going to use the pointer member variable and it's going to account for it in the size of your object. Hopefully you can understand why the size of our string object is going to be the same regardless of how large is the string. And this is really something you need to understand. Otherwise, this is going to throw you off as you design your C++ applications. And this is really all I had to share in this lecture. The size of your object is mostly going to be determined by the member variables you have, and the size is going to be the sum of the sizes of your member variables. I would like to...
Okay, that was a sudden ending, but I was kind of expecting it at this point. So that's kind of that's an interesting lesson. I do think this feels like the kind of thing that becomes really important when you have a lot of different objects interacting and like potentially a lot of memory being used. So this being wary of that, I guess, is kind of the takeaway from this. It is. I do think it's interesting that in all the ways we've seen it, so size of name being 32. So like the string thing is bigger than our object, which I think is kind of funny in a way. But also when we saw that it was it seems to take the it goes in 8 bits or 8 bytes sections. So like when we had two 8-byte ones, it was like, okay, that kind of makes sense. When we had two 8 bytes and then we added a 2-byte thing to it, it suddenly took up 24 instead of taking up 18, which is the what I was kind of expecting, but it didn't end up working out that way. You've learned about bit shift. Kinda. We learned about I learned how this is necessary in order to make all of this work. I understand the name bit shift, but I don't quite understand its function. Think of a short. It's a minimum 8 bits, but you only need 2. If you have other shorts you only need 6 of, you can combine them with shifting. Then you just gotta read the correct bits out at the end, basically making a small data protocol for yourself. Holy smokes. So have you had to do this before? I mean, you talked about it was a devlog that you I assume that you read about or that you read, and not me, no. Okay, so you haven't actually had to implement this. It sounds super cool though. I was like, hey, we need to be like hyper efficient about this. That's super interesting. Okay, I'm gonna go ahead and make I put these away. We have a lot of projects for this week. All right, hold on. Week 4. I don't remember. So the first week, oh my god. So first week had 12 projects. Second week had 20, got us up to 21, so there was 9. The third week only got us up to 29. And this one got us up to 47. So this one I had to make new code a lot. Skip that one. Okay. So we're going to go ahead and I have to make a bunch of new folders, unfortunately. Give me a second. I'm sorry. There's no scuff here. No scuff whatsoever. Don't even worry about it. Project 49. I'll just make up to Project 50 for now. Hopefully that doesn't take up all the rest of our time. Or it doesn't take up all the rest of our projects over the course of the day. All right, let's see. We got open folder, Project 48. So then we should be able to take this and put it into the folder. Boom, like that. I'm going to make another folder for when we put all the stuff into this one. We're on week 5. That's kind of impressive for me. All right. Move all this stuff in. Sweet. Okay. We are now prepared for the beginning of inheritance. So, let's make this larger, and we're going to watch our the lecture portion of this for inheritance. This is going to be the actual start of the chapter. You know, only half an hour into the stream, no big deal or anything. So inheritance is the first like really big section, I think, or it's the second longest of these of the chapters. If you've seen how long some of these fucking things are, it's like, oh yeah, classes was like it was like an hour between concepts, and then classes was like the longest one up to that point, and now we're on inheritance, and that's going to be another 2.5 hours, and then polymorphism is going to be 5 hours at least. So we'll look forward to that. It's used in Factorio, where they have to stay under 16 milliseconds per game tick before frame rate suffers. Really? Some of the optimizations in devlogs are insane. That sounds crazy. Maybe I should play Factorio. I've heard Factorio is like a good analog for certain coding concepts, but I've never been a huge like automation games guy. Like I played Slime Rancher. I tried to optimize that one a little bit, but not even close to like optimal. But then things like I had a friend I played Satisfactory with for a bit. This same friend who plays so many different versions of modded Minecraft that I just cannot wrap my head around. I can't even begin to imagine how some of this shit works. Anyways, we have inheritance to do, so let's go ahead and watch that. Gakwaya Sensei, take it away.
To welcome you in this new chapter where we're going to be learning about inheritance. And inheritance is a feature that C++ provides to allow us to build classes in terms of other classes. And what I mean here is that we can build complete hierarchies of classes that depend on other classes. For example, if we think of a person as a type, we can have different types of persons. We can have a doctor is a person. We can have a physician is a person. We can have an engineer is a person. We can have really all kinds of persons. And we can capture these kinds of relationships in C++ using inheritance. For example, here we have an inheritance hierarchy. We can set up a person type in our C++ program and put in whatever member variables we need to define a person for whatever purposes we are building our C++ application for. Once we have this type, we can build other types that depend on this person. For example, we can build an engineer type, which is really going to embody the person type inside. So what we will be doing is really setting up a layer of a person type, and in our engineer type, which is going to depend on person, we will build another layer on top of that and really reuse that person type without having to rebuild this from scratch. Hopefully you can see that this is going to improve code reuse. We can also reuse this engineer type and build other types on top of it. For example, we can have a civil engineer, we can have an electrical engineer, we can have all kinds of crazy engineers modeled in our C++ program using inheritance, and this is going to be really cool. So this is what we are going to be exploring in this chapter, looking at the facilities that C++ provides to capture these kinds of relationships in our C++ programs. Please note that inheritance is a really big feature, and it is a defining feature of object-oriented programming in C++. Object-oriented programming is a paradigm or a way of thinking about programming that uses objects. And the most basic defining feature of object-oriented programming in C++ is classes that we have learned about. Using classes, we can define things. For example, we can set up a car, we can set up a house, we can set up a spaceship. We can do all kinds of crazy things with classes in C++. Inheritance is going to build on top of classes and allow us to build classes that depend on each other and build complete inheritance hierarchies that are going to make our design much easier to look at and understand and work with. Okay, so this is what we are up against in this chapter, learning about inheritance and really exposing you to as much as possible to let you use inheritance in an easier way in your C++ programs. We are going to start in the next lecture and try out inheritance for the first time. Go ahead and finish up here and meet me there.
Okay, so that kind of makes sense to me. Basically, put the way he explained it, where you have like person and then a subtype of the way I'm thinking of it is like subtypes, where you have person and then you have a subtype of person that is engineer, which has all of the traits of person and then some other defining characteristics. And then he has civil engineer, it has all of the defining characteristics of person and all the defining characteristics of an engineer, as well as some other defining characteristics. And I assume that this can be kind of branched out so that maybe you don't have engineer and instead you have like artist or something as your other as like another type, and then like you can have subtypes of that where it's like, okay, this person like does drawings, this person makes music type deal, and it's like and you kind of build based on that is kind of the way that I'm understanding it. It doesn't seem super complicated at first blush to me. Factorio takes a certain kind of person to play lots of. Performance is the prime concern in its dev, given that it has to potentially render millions of individual sprites at 60 FPS, a top game logic. Or better phrased, it has to perform the logic of potentially millions of entities at 60 FPS. That sounds kind of like a lot. And I've wanted to try Factorio, but I've also been afraid because it's one of those things where like I don't want to like buy a game and then find out it's just not for me and then feel bad about it. But at the same time, like whenever I've tried to play something that's like co-op, I feel like I just get left behind immediately when I play with my friends who do know shit about like modded Minecraft and the like. So I've like I'll be sitting there like mining some copper, like I don't know what the fuck I'm doing, and then like I come back and we have a nuclear reactor that I'm like I have no idea how it works or how we acquired any of these materials. Let's see. I'm getting pinged. Oh, it's just a random ping. Okay. First try on inheritance. All right, let's see what Gakwaya Sensei has to say about this.
We're going to try out inheritance for the first time in this course. But before we do that, let's remind ourselves of what inheritance really is. Inheritance is a feature we have in C++ to be able to build new classes in terms of the classes we have predefined. And the new classes are going to be stealing features from the already pre-existing classes, if I can say it like that. And the more classes we build in terms of others, we're going to end up with what we call an inheritance tree, which is basically going to go from the top to the bottom with the most fundamental class on top and a derived class at the bottom. Here we have a simple example. For example, we can have a person class, and this class may be defining the basic features of a person, but based on that person class, we might want to derive other classes that build on top of this person class. For example, we might want to define an engineer and a doctor, and we know that an engineer is also a person, so they are going to inherit some features from the person class. The same goes for the doctor class. It is going to inherit some features from person, but all these derived classes are also going to add their own features to the person class. C++ allows us to build these kinds of relationships. Here is another simple example. We have a vehicle class to the top of our inheritance hierarchy, and below this class we might derive a truck class, which is also a vehicle. We might
Hey, wait a
have
second, there's
minivan,
two trucks.
we might have a truck, we might have a pickup truck. We may really do all kinds of crazy vehicles, which are going to inherit the basic features from the vehicle class and add their own specialization on top of the vehicle class. So this is the basic idea behind inheritance in C++. So the examples we're going to do in this lecture. So here is a simple example of what we're going to do in this lecture. We're going to set up a person class, which is going to be our base class. It is going to be defining two member variables, which are going to be of std string type. We're going to have a last name for the person and a first name for the person. We are going to derive from this class and set up a player class. The player class is going to inherit these features from the person class, so it is going to have a last name and a first name built into it, but that's going to be our base or our starting point. We are going to add to this base and add another member variable from player, and we're going to be having a player class, which is really a person, but it is going to add things to person to customize on what we can do with a player that we wouldn't originally be able to do or have with a person class. This is the basic idea. Okay,
Makes
now
sense.
that we know this, we're going to set up our person class, which is going to be our base class. It is going to have our two member variables, first name and last name.
Mysterious
we're going to
person.
have a bunch of
Nice.
constructors, and we're going to have a stream output operator to be able to print this on the console and see our information here. Nothing special. But now
Nothing
that this
special.
class is done, we
No
can
big
build
deal.
other classes on top of this class. So what we can do, for example, we can derive a player class. So the syntax is what you see here. We say class player, we say colon, and then we say public and specify the class that we are inheriting from. So the parent class for this class is going to be person, or in other words, we're going to be deriving from the person class, and we're going to be doing that publicly. Okay, for now, I don't want you to worry too much about this public keyword. We're going to be learning this in steps. Just know that this is the syntax you use to derive from another class. Now, the moment we do this, the player class is going to have the person information embedded inside, but we will also have the ability to customize or add other things at the level of the player class. This is what we do. We have a private member variable, and it is going to specify the game the player plays. We're going to have our own set of constructors. We can really build player objects, but they are going to have a person part inside that is going to store information about this player person. You notice we don't have a member variable here for the first name. We don't have a member variable here for the last name, but that information is going to be baked into this player object. And this is really how inheritance helps us
Inherits
out.
behind you.
We can
Nothing
derive from
special,
classes
kid. Oh my
and
God.
build on top of them without having to redo the fundamental work to build our base classes. We can just build on top of them and really do things faster and more efficiently. Okay, so here are a few things you need to know about the public inheritance that we just did. And we are saying public inheritance because of the syntax we used here. Public person, this is doing public inheritance, and we're going to see what this gives us. So with public inheritance, derived classes can access and use public members of the base class, but the derived class can't directly access private members from the base class. I want you to let this sink in. What this means, from the player class, we can't directly access the private member variables we had in person. Remember, our first name and last name are private to person, and we can't directly access them in any deriving class that is doing public inheritance. Okay, so in our player class, if we try to access the first name and the last name, we're going to have compiler errors because we can't directly access them. But not to...
Doesn't that mean so okay, this is a little bit this is me kind of jumping ahead a little bit maybe. Isn't doesn't this mean that if we make a like we've defined a player class, like if we make a new player object, can we doesn't that mean that we can't actually fucking doesn't that mean we can't actually edit the name and stuff, or is there some other thing that he's going to tell me that we can do for that? Wait, so Factorio used the wasted bits by shifting? That's crazy. I mean, I wouldn't be surprised. That game seems kind of insane to me. But yeah, maybe he will explain to me how we can change a player's name.
Worry here, we can still go through the public getters that we have in the person class to access the private
Oh, we just have to use the getters.
The base
okay.
class, and that's what we're going to do in this lecture here. Because
you can still use name. He should tell you about that. Yeah.
Tools we're going to learn about in the next few lectures. The same is also going to apply to friends of the derived class.
Friends?
They are going to have access to private members of the derived class, but they don't have access to the private members of the base class. If you try to access the private parts of a base class from a friend of the derived class,
player class also inherits the constructor.
Errors. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more and really drive this home. Here we are in our working folder. The current project is First Try on Inheritance. We're going to grab our template files and put them in place. Let's do this.
I can't. This will hopefully enlighten me. I'm better when I actually get to put my hands on things and try it out.
And we're going to have our main CPP file. We can clean this up a little bit. And we're going to add our classes. The first class we're going to add is the person class. So we are going to create its header file. And let's do the CPP file.
Oh god, we got to create a header file? Oh shit. Okay.
I am going to grab the code I have lying on my drive for the header here. I am going to put the class in. We are including the classes we're going to need. We need string and IO.
Oh god, okay. I need to... If I knew what I knew... We gotta make sure we get our person class set up properly. Person H. Okay, so we're gonna include string and include IOStream. So class person. So this is going to be where we define what a person is. Hopefully this doesn't get me in trouble. All right, so friend. I don't know what friend is. STD OStream address operator. STD OStream address out const person address person. So we're using a reference to person a lot. I don't know what exactly this friend thing is. I'm hoping he goes over and explains what that's supposed to be. So you go here, we have public, which was it classes that were private by default? And that we had to open up publicly, or was it was that structs that were private by default? I don't remember. Person. So that's our default constructor. This is our next constructor. A person has std string first name param, std string last name param. And then we have our destructor for person. Make sure that this looks properly. std string first name param, std string. Close this real quick. Last name underscore param. It's a good thing that I looked at it. Okay, so this is our... These are like the public things by the looks of it. So we have a person which has nothing, and then a person which is just a name, a first name, last name, which makes sense, and then we have our destructor for getting rid of it. So this is our getter, or getters. So we have our string get first name, and we get a const return first name. That doesn't seem... All this does is just... Wait a second. Wouldn't I have to do return? No. No. Hold on. I might have to continue going because I think right now... Yeah, so first name is undefined. I assume first name will get defined at some point. String get last name. Not num name. Const return last name. Still, that's also going to be undefined for now.
For the class n, we are including the classes we're going to need. We need string and IOStream here because we...
Okay, yeah, and then the private is where we have our first and last name. Okay, so private, and we have our std string first name. I don't know why it keeps doing that. Mysterious, and then we have our... I don't know why I went with C out there for some reason. String last name person. I always want to call, whenever I see Mysterious, I want to be like Mysterious Johnson. But that's not actually a thing that anybody's going to get.
We're going to be outputting thanks through the output
Very
stream operator.
mysterious.
And down here we have our two member variables. We have first name and last name. They are of std string type. And we have a bunch of constructors here, a default constructor and one that takes two parameters. We are taking them by copy here. This is bad. We should at least pass them by reference here. Let's correct this pretty fast. And we're going to make the second one a reference as well. Let's do this. And we have a destructor, which is going...
I think this is the main thing that I don't understand for now. I don't remember what this is supposed to be. With public, with the constructor, I kind of understand. It's like, so we have our person. So if we create an object person, we can call it person one. Then, like person one, I think this is the default name essentially, but we could create one with whatever parameter we want, and it would change the address of this, if I'm not mistaken. Or not, it's not changing the address, it's changing the data at these addresses, right? Or am I fucking high? No, wouldn't it? It wouldn't be, because this is string reference first name param, last name param. Do we not have something to replace the names?
going to do nothing because we really
Yeah, we don't have any fucking setters in here. We have getters, we can get the names, but this, I don't think this does anything, does it?
Doing any dynamic memory allocation here. We're going to head over to the CPP file and put in the code for that. We're going to include the person, and we're going to do our constructors, put in the implementations, I should say.
Wait a second. Oh god, have I fucked this up already? Did I not listen? I didn't listen. Okay, hold on.
And we can clean this up a little bit. And we're going to add our classes. The first class we're going to add is the person class. So we are going to create its header file, and let's do the CPP file. I am going to grab the code I have lying on my drive for the header.
Okay, so I'm a fool. I'm gonna go ahead and just copy all of this, or cut all of this, put it in the header file. This is our header file. I don't know what the fuck. I don't know why I didn't pay attention to that.
Here, I am going to put the class in. We are including the classes we're going to need. We need string and IOStream here because we're going.
If you create a new person with first and last name, it replaces the standard mysterious person. Does it? Hold on. I mean, I understand that's what we should be doing, but I'm not understanding. Oh God, this is what I get for not looking at that code for like 4 days or some shit. It was way too long, way longer than I wanted it to be. Almost a week. So this one takes our parameter. This one takes the parameters. So this is first name param, and then this is last name param. This just returns the first name. Hmm.
To be outputting thanks through the output stream operator. And down here we have our two member variables. We have first name and last name. They are of std string type. And we have a bunch of constructors here, a default constructor and one that takes two parameters. We are taking them by copy here. This is bad. We should at least pass them by reference here. Let's correct this pretty fast. And we're going to make the second one a reference as well. Let's do this. And we have a destructor which is going to do nothing because we really aren't doing any dynamic memory allocation here. We're going to head over to the CPP file and put in the code for that. We're going to include the person and we're going to do.
Okay, so we have here include person.h. So here we have person in the scope of person. And we can do like this number. So here person in the scope of person. STD string first name param STD string last name param. First name param. God damn it, what's the fucking button? Last name param. So I don't know why this is the way that it is. I don't know why we have these like this, but I'm just going to make sure my shit looks similar. So like this to me makes sense. This looks like it's or not like it makes sense, but what is I'm curious why this is like this. It says it's expecting a close bracket. All right. STD output stream address operator STD output stream address out const person address person out person. Oh god, more wackadoodle frickin' text so that we can make it look nice in the terminal. Person dot first name person dot last name. Return out. And then here we have our person Destructor person. Which I also don't understand why that one is like this. I don't understand this. I'm sure there's a reason for it. It might just be to space things out and make it more readable. No instance of overload function person matches specified type. Well, he has the same error at the moment, so let's see if we have to fix that.
Our constructors, put in the implementations, I should say, and we're going to pass our parameters by reference again. Let's do this. And our constructor should be done now. We have a person class that we can use to derive other classes and use this class as a foundation to build other classes. To visualize this again...
Whoa, hold on. So, between these two things, we should know this is the foundation of the person class. Okay, so we've created a class called person. I'm curious what this... Is this just our setter or something? So when we create a person... If we create a person, std string address, first name param, last name param. First name becomes first name param, last name becomes last name param. So this is a reference to a string for first name param. So that, I think this is what lets us set our person object's name and first and last name, I should say. Unless I'm mistaken about that, I think this is what lets us actually do that. And then this returns it. This will, like, this should essentially just print it, is the way that I'm reading that. I feel like I'm a little bit lost as to what this operator bit shift thing is. And also output stream. I don't recognize output stream as something that we've been doing. I guess we just continue.
Class as a foundation to build other classes. To visualize this again, our class person is going to be the base class for our player class. So if we build a player class, it's going to have a person part of it, which is going to be the foundation on top of which we're going to build. Notice that in player, we don't need to set up last name and first name. They are going to come from our person part of player. All we need to do in player is set up the game member variable to make him a full player who can have the game they happen to be playing. This is the idea here. Okay, so now that we know this, we're going to put in our player class. We're going to create the files for it. Let's do player.h. Going to...
Oh man, okay. I'm not comfortable with this at the moment. Player.h.
Put this in, and we're going to do player.cpp. We're going to put him in. We are going to hop over to the header file and put in our code. The class is going to be player, and it is going to be inheriting from person. This is the syntax. Again, we say colon colon. We say the kind of inheritance we want to do. In this case, it is public.
Wait, so are we just copying... Are we just copying the player... Or the... Oh wait, no, he copied a whole fucking new thing. Okay, hold on. Ugh. Okay, so we have if and def player h define player h. So we're including string We're including IOStream, and we're including our person thing from before. Oh, we'll get to that one in a bit. So from here, we're creating a class called player. That's using the public stuff of person. So here we have our friend, std output stream operator, or address operator, std output stream out const player address player public. So then this is the stuff that is unique to player. All this stuff that we're actually writing is kind of my understanding. So I do player default player, and then this is our std string game param, and then we have our destructor player. And then we have our private std string m game none. So by default, looks like our game member is none. And then we do this and go to end if player h. Okay. So this takes... I'm curious to see how this is going to end up, how we're going to end up using I also noticed we don't have a getter for the player class. Presumably we'd want to, I think we'd want to get the game, right? But I'm curious how we're going to end up creating an object with this this setup, because that's kind of the thing that's confusing me at the moment. Because like with this one, I think that the way it works is we could create a person and then give it first name, last name, and it should create an object with the first name, last name that we have, or that we give it. I don't quite understand the logic of how the code is doing that. I could be wrong, and then I'm just making an assumption here. But I think that's what we're supposed to be doing. Where's my... No, I should probably create a new terminal. We got problems. Surely. No problems? Really? Okay. I'm gonna make this smaller for now. Maybe... The hell? Oh, that's me, not you. What the fuck? Weird. Weird.
And then we say the class that we are going to be inheriting from. From this point on, the player class is going to have a person part of it, and we are going to prove this in a minute when we run this code here. Notice that we can build player objects by just passing in the game parameter here, which is going to be used to initialize our member variable. Let's also make it a reference because this is good practice. It is going to avoid...
We want this to be a reference.
Copies. You can even use string views, but that's going to be your choice. We are going to hop over to the CPP file and put in our implementation. And this is going
Our implementation. Okay.
CPP file and put in our implement.
So this one's supposed to be our player.cpp. So we haven't created that. Let's create that. Player.cpp. So this one will include person.h, and this one will include player.h. And we have our player in the scope of player, std, string address, game param, member game param, and then so we have that. That looks like it's the same. OStream ampersand operator. See OStream send out const player address player. I really don't feel like I'm part of the issue I'm running into right now is that I'm not really feeling comfortable with what we're doing. I'm hoping that it gets clearer as time goes on. Like I understand in theory what we're doing, but unlike how a lot of it has been so far, this part I'm not really feeling was explained in a way that I could easily comprehend. Names player get first name player not get last name. I have an extra M again. Then we do this thing, return out. Yeah, so this I'm kind of unsure of, because this is like one really long line essentially. So we have our output stream. This is just a print, right? There's always W3 schools for text-based tutorials. True. I have considered maybe going through the Code Academy course as well, but the problem is that I'm in such different places between that and this video. I feel like it would take a long time for me to get caught up and to uh I don't know, maybe I do like a marathon stream for it or something. Not even marathon, just like going through the Code Academy course, because it's a little bit more. It's a little bit like um. Let's check out this one. Check this out. Okay, yeah, it's this. It's another similar website, different but same kind of idea. There's like a well at least with the Code Academy one, I have to it gives me exercises, and I assume based on how this one looks that it's kind of the same deal. Where like, hey, here's an exercise for you to do, and if you do it incorrectly, you can look at it. There's also like Learn CPP. We've looked at a few different ones before. This is like the main, I, I wanted to just do this video, and it's been great up to this point, and I'm kind of hoping that this gets explained, because it usually does. Usually I'm like just, I'm having a skill issue, and I just, and it's and I'm freaking out unnecessarily. But I would like to feel comfortable with all this stuff. All right, so we have our player class. All right, let's see.
And this is going to complete our setup for the player class, which is going to be inheriting from our person class here. We can actually head over to the main CPP file and include the player class. Let's do this. We're going to say player, and we can create player objects. Let's look at the code again. For a player, we have a constructor, which is going to take a string parameter. We can use this to create a player and specify the game they are going to be playing. But for now, we don't have enough tools to put in the data that would initialize the member variables in the base class, which is person here. If we go back to person, we're going to see that we have the first name and the last name. But in our player class, these member variables are going to be inherited because a player is inheriting from a person. This is the syntax to do that. But even if the player class has a person part inside of it, we can't really access private members from person from a player object. We're going to see a few ways we can get around this. And one of those is to go public methods from the person class to access private parts of the person class. This is going to give us access to these member variables. If you go down in our stream output operator, you're going to see that we are using these getters here. The parameter is a player object that we want to print out, but to get access to the names, we are getting the first name and the last name through our getters here. Before we really explore this any further, I think it is a good idea to go in the main CPP file and
Wait, where did we define this function? Player.get last name. Okay, here we are. So we have our. Okay, we defined it here. We have get first name and get last name. Okay, that's right. So yeah, so what this so all this one is doing, if it's for our player, we're getting the game and then the. What is it? I need to see this. So we come here, we look at it, we have our operator. Oh my god. It's funny, I've been told that the header files are like archaic at this point and not really used in languages outside of like C anymore. So we have our O stream, output stream operator, and it takes the parameter of out const a const player address. Oh, fuck me, dude. Yeah, we don't want to edit the player address. That is one of the things that it's doing, I guess. So no headers? Oh my god. So no headers? Alright, so here we have player. This is just text saying player, their game, and then it has the game that they play. And then their name, and then it uses player, and then we get first name, which is because it's an extension of person, it has access to this thing. This because this is still public. So it does get first name, and then it does get last name, and then it closes that statement. So this is essentially, if I'm not mistaken, output player name and game.
create a player object. So we're going to do that. We're going to say P1 and we're going to specify that they play basketball. Why not? Okay, so we have our player object and we can really do all we want with it. For example, we can print the information about this player object. If you remember, in player we have a stream output operator which is going to print all the information. And here we have a problem because this guy is taking the data by reference. And this is not a reference, this is a temporary object that we are passing here. So we could go back and change this to take a string view parameter. Let's go back and do that. We're going to include a string view here in player, and we're going to change our parameter to be std string view by value. And we're going to do that in the CPP file. Let's do that. We're going to say
Hold the fucking phone. Okay.
and we're going to do that
So we come here, std string view.
in the CPP file. Let's do that. We're going to say std string view. And this should take care of our problem here. You see that the problem goes away. Now that we have this guy, we can print it out. We can say stdc out player and put the information out. Okay, so now that we have this, we can try and build our program. We're going to use GCC, our favorite compiler, and you're going to see that we have a problem, undefined reference to player destructor. Let's go back in the header and see that we have a destructor, but we probably didn't put a destructor in the CPP file. So let's do that. Or because we're not doing any dynamic memory allocation, we can even completely take out this destructor, and we're just going to use the one the compiler generates for us. This is going to be much easier to handle in our code, so we can build again with GCC. Okay, the build is good. We can run this program, and let's see if we have a PowerShell window. We don't. We're going to bring up a new one, and we're going to run Rooster. We should see information about our player. So player, the game is basketball. The names are mysterious person, because that's the default data we inherit from person. If you go back to person, you're going
I think I understand that. So when we go to our player.cpp, it prints out all of this information. Oh gosh, I am so... So it does this every time that we function member function get first name should return first member by const reference. If we look for is that by const reference? Oh god. What the fuck? Well, that's not like a compiling issue. That's just something that we're copying this guy. But it seems like what it wants is for me to change this to a const ref, like so. Surely it would want both of those then. Should return member first name by const reference. I'm not going to start messing with stuff just based on this. What I want to understand is why this printed out exactly the way that it did. Because what we did, by the looks of it, is create this, and then we called it to, okay. So what we did, we created a player object called P1, and we fed it the data basketball. So then when we went through here, went out, we printed player exactly as anticipated, and then we went to P1. P1 prints it prints a player object. So let's go into our player header. So we have our class player, which is which is a subsection of person. It's a fucking it inherits the values of person as well. So then we have here person. I don't know what this friend thing is. I'm actually still confused about this. I wish it had been explained when we were doing it. It seems like it seems very extraneous. Like it doesn't seem to do anything of value at the moment. Um, so I don't know. So what defines a person is we give it a name, which is a string it's a string reference, uh, first name and last name parameters. And then we have our get first name, which we're returning as a const, or which is, okay. We have two getters, which will get us the name, ideally, is kind of the way I understand it. We have get first name, which accesses the private function and returns the first name. And then we have get last name, which accesses the private portion of the not private function, but you know what I mean. The private the private portion of this class. By default, this is filled with mysterious person. So because we haven't edited the person part of this at all, our player is going to be named mysterious person. So then when we go to here, I still don't understand the friend part. That's also here, but now it has player instead of person. Up here, and I still don't understand it. I feel like it's important somehow that I understand what this is. But in any case, we go to our player, and our player has a default constructor, and then we have a constructor which gives a game parameter, which we gave it when we fed it basketball. That's what it would have been. That's what it would have. So then in our private, it initializes the game, our game member as instead of being initialized to none, this is initialized to basketball. So my understanding then is that the CPP file, when we do it, or when we call P1 the way that we did, it just goes through this and outputs the player name and the game, which is what we see here. I guess I should say game and name because that's the order that it happens, but it doesn't really make a huge difference. I don't understand why this I don't understand the output stream stuff, because this is again, this is here in all three of these files, and I'm willing to bet that it's in player.cpp or person.cpp as well. It is, and I don't understand it. And we have our person destructor. So if we, God, what defines a person? A video essay? Oh my God. No, I'm not trying to start any moral issues. It's just it's a programming class. Okay. If we create a person object, if we just do person and we'll just call it rag. Person rag, and we'll go with rag narok. This, if we do like this, let me just do like so. It should just print essentially this, but like the name. It's kind of the way the way that I'm reading it. Terminal run task. Oh, see, that didn't work. This is a, oh god. Basic string address, first name param, last name param. Okay, so it looks like our first, okay, hold on, I gotta try and read this. Cannot build non-const L value reference for type std string address to an R value type std string. So what this seems to be telling me is that this doesn't work. Is my understanding of that. Is because we're passing an address. So we aren't able to just create a person at the moment. Alright, I'm going to not mess with this. We're going to get rid of these because I don't understand it, and I'm hoping that it'll get explained.
We're going to see that the default data in first name is mysterious, the default data in last name is person, and it is what we see printed out here in our PowerShell window when we print information about our player object. Another thing I want you to see is that we can actually really prove that any player object is going to have a person part of it baked in. And that's going to be storing the information that is modeled into our person class. And we can use a debugger to do that. For this to work, I am going to put a breakpoint here on line 8, which is printing things out. This breakpoint is going to be hit after our object is set up, and we can really see the data inside this guy here. So what we're going to do, we're going to hit this run tab, and we're going to use G++. We're going to use the debugging tools that come with GCC, because this is our favorite. We're going to hit the green button here. This is going to start our debugging session. A binary is going to be built, and it is going to be plugged into our debugger, and we're going to hit our breakpoint here. Now, if you look on the left here, you're going to see a title that says locals. We're going to expand this, and we're going to see that the P1 object actually has a person part of it. And you see that Visual Studio Code is being helpful here. It is saying that this is the base class. And if we expand, we're going to see that we have our member variables. We have first name and last name. And this is a player object that we are looking at. Don't forget that. And on top of our person part, we also have our own member variable, which is the game that we play. And it is right here. Hopefully this proves to you that any derived class object is going to have a base part embedded into it, and that's going to be the foundation on top of which the derived class is going to be building its own thing. This is the basic idea here.
Right.
Okay, now that
makes sense.
we're going to kill our debug session,
and
we're going to see some of the things you need to be careful about when doing public inheritance like we are doing here.
Okay. I was kind of hoping that he would go into a little bit more what some of this, like, I still don't know what output stream is. Here, what if I try to do a little bit of Google foo? What is CPP reference OStream. So OStream, this is basic OStream. I don't know. I don't think that's the same thing. If I go to std OStream, all I'm seeing is basic OStream, and I don't know if that's the same thing or not. High-level output operations on character streams. The supported operations include formatted output, example integer values, and unformatted output, e.g. raw characters and character arrays. This functionality is implemented in terms of the interface provided by the basic StreamBuff class, accessed through basic iOS base class. In typical implementations, basic OStream has no non-inherited data members. 6 global basic OStream objects are provided by the standard library: cout, carr, wcarr, clog, and wclog. Member types, member functions, member classes, non-member functions, inherited. Oh god, it's such a... This is all documentation. So it seems like OStream is... But this says it's defined in the header, which we haven't had to do. OStream, okay. Output stream objects can write sequences of characters and represent other kinds of data. Specific members are provided to perform these output functions. CR, cout, and clog are objects of this type. Instantiation of basic OStream with the following template parameters: character T, alias is member character type. So is it just essentially an std cout? I don't...
The first thing I want you to see is that you don't have access to private parts of the base class. If you go back to person here, let's kill this so that you're not confused. If we go back to our person class, we're going to see that our first name and last name are private. So they won't be accessible to any class that does public inheritance like we are doing here. They are just going to be private. They are going to be part of the class, but the derived class won't have access to them. This is the idea here. And if we go in our output stream operator and comment out what we have here and try to directly access these member variables, let's do that. I am going to copy the code here and put that on top. And we are not going to go through the getter methods from the base class. We are going to try and access mFirstName. Let's go back and look at the names for the member variables. It is first name.
That's just not going to work.
Name.
We already know
Let's
that, right?
use that. We're going to say first name. You see that through IntelliSense, but trying to access that is going to give us squiggly lines. You see that we have this in our autocomplete,
and it won't build properly because you don't have access.
We can't access these. If we try to compile our program,
that much I understand.
Again. We're going to use GCC and we are going to get compiler errors, and the compiler errors are basically going to say first name is private within this context. Again, the meaning is that first name is private to the base class and we have no business accessing that in a derived class, which is the player class here. This is the meaning. So we can't really access that. Okay, I realize this is a global function, but even if we try to do that from a member function, let's do that from a constructor. We're going to try and say first name. Okay, I realize the access we are trying to do from the output stream operator is really not a good example because this is not a member function. It is a global freestanding function. So we can try and change the first name and last name from the constructor, for example, and we're going to see that this is not going to work either. So we can take this out and we're going to remove our block comment. So we're going to take out what we just did here and we're going to uncomment our good code here, which is using getter member functions from the base class. And we're going to try and change the first name and last name from the base class and change those into our constructor of the derived class. We're going to try and change, for example, the first name and make it John. And we're going to take the last name and change that to Snow. Let's do that. And let's go back and make sure we have
it's still
the
going to
correct
be
names.
It still
And you see
says
that we
don't
have
have
squiggly
access.
lines. We can't really do this because these are private members of the base class and we can't access them from a derived class. They are part of the player class, which is a derived class, but we don't have access to them. We can't modify them or do anything. We can't read from them. We can't write from them. This is the message here. If we try to build our program, we're going to use GCC to do that. We are going to get compiler errors, and
Private within this
let's
context
see
still.
the compiler error we get.
I mean,
Again,
that's
the error
all
is
well and
that first
good.
name and last name are private to the base class, and we have no...
I guess what I'm kind of confused about, I mean, OStream is just one thing, but like, I guess another thing that I'm kind of, the main thing that I'm not sure about is why just calling it, just calling the player prints this stuff. I mean, I guess it kind of makes sense because like when we do it like this, like we create a player and then it just prints and it'll print the data that we gave it. Like if I could change this to whatever I wanted. It doesn't even have to be a game really. But I could as long as I feed it some input, it uh it'll print whatever I put in the game thing, but I still can't change the name here at all. And I think it, if I'm not mistaken, the reason that it prints is just because this I'm actually I think part of the reason I'm confused is because we have both the header and the CPP file. And like I understand do I? So if I go to main, what do we have? We're including player.h. And player.h includes person.h. So and but then player.cpp includes person and player. This actually, I wonder if this is even redundant. Like I want because player already includes person. I wonder if you could just do person. But then the CPP thing, this this is a, why does this print? I think that's what's confusing me. Because are these functions? They're not functions. I think it's these CPP files that are fucking me up. I think that so these things must be connected by the linking portion of building this, of when we compile the code. And these CPP files include the person header files. But we don't actually need to include like player.cpp in order for the player data to print. There's a piece of this puzzle that I'm not understanding, that I'm missing. And I don't know how best to go about it. How do we... How long have you been studying this course? Well, this is on hour 23. We're doing our first try on inheritance. And I'm kind of... We did a little bit of stuff with code across multiple files like this before, but for some reason it's not clicking right now. There's something that I'm not understanding, but I can't put into words exactly what it is, I don't think. I know that when we do this, like all we do when we do this, right, is that it has multiple. We have multiple classes defined, and we have our person, and then we have our player, which inherits person. So player has all of the same data and more. So when we call it by giving it, or so when we create a player object with the game basketball, because that's what it's supposed to be, it goes through like we have all of our information. So when we print this, I think all it's doing is it comes to here and just runs what's in here. Almost the way, not quite like a function, but kinda. Is this guide good? Would you recommend it to others because he looks crazy? I mean, up to this point, it's been pretty good. I'm a little bit skeptical about this chapter. There's been a few moments here and there where I've been kind of like, I wish things had been explained a little bit differently. But overall, I've been able to follow along pretty well. At the very least, the concepts are pretty strong. Like understanding the how and why is pretty good. My biggest complaint overall is understanding. There are a lot of times where he'll say like, "Hey, this could be very useful," and if it's more useful to do it one way over this way, then maybe do that instead. But like, he doesn't give any examples as to why one might be better or than the other in a given situation, which I find kind of frustrating at times. But it is, I mean, at the very least, learning all of this, I can understand most of this stuff. I think the thing that's messing me up is just these having so many different files is kind of throwing my brain for a loop at the moment. Let's see.
Business accessing them from a derived class like we have here. So if you need any kind of access to a private member of the base class, you will have to go through something that is public, and a good example is getter methods, which are going to allow you to change things. So for example, if we want the ability to change the first name and the last name, we can set up a bunch of setter methods. Let's do that. We're going to say setters, and we're going to say void set first name, and we are going to pass an std string view. Let's do that. We're going to say string view here, fn for first name. This is going to modify our class, so we are not going to mark this as a const member function, and we're going to say first name equals fn. This is going to do. We are going to set up a setter for the last name set, and we're going to pass a string view here, and we're going to say ln for the last name. Again, this is not going to be a const member function, so we're going to say last name, and we can pass in ln as our new name here. Now that we have these in, we can take out these things.
Slow down. I need to catch up. Std string view ln. Get rid of this thing. Last name equals ln. Let's make sure our stuff looks. So we have last name and first name. So this one should allow us to change the name of a given player. It's kind of the way. Okay, so I was right. We didn't have any freaking setters. I just realized I said that like half an hour ago or more. I was like, we can't actually change the name of any players that we have.
Name here. Now that we have these in, we can take out these things we have in the constructor. I think the job for this is done.
Yeah, I didn't
And
write
this
those
is
in
going to give you
because
compiler errors.
they
And we can go in
just
our main
don't work.
CPP file and change the names for this person here. For example, we can say P1 set first name. We're going to pass John. And we can also set the last name. We're going to say P1 set last name. And we're going to pass Snow. And this is going to do, if we build and run this program, we're going to see that the build is going to be good. This is the first step. And if we run, we should see the information printed out. We want Jon Snow printed out, and the game should be basketball. Let's clear and run Rooster. We're going to see that the data
So now
is in
instead
here.
of mysterious person, now we have Jon Snow. Setters will be the villain faction in the next Thief game. Will it be? Instead of oh, because the thieves are the getters. They're just gonna steal all the different things. They're the getters. Pointer is coming. What do you mean Pointer is coming? Bonsai. Pointers were how fucking long ago were they? Pointers were 10 chapters ago. We're on chapter 18, man. Oh, Jon Snow. Yeah, see, I haven't actually watched Game of Thrones. So that the reference flies over my head. Like I understand that it's like, oh, winter is coming. But like that's only because I was on like fucking 9gag in 2012.
Jon Snow, and we have our game to be basketball here. But notice these are base methods, and we are calling them from a derived object. And this is living proof that the public members from the base class are going to be inherited and usable from a derived class that does public inheritance like we are doing here. And this is really the main message. You
Bro had that
inherit
SR-71
publicly and
altitude
have
miss.
access
Shut
to
up!
public stuff from the base class and use them in your derived class, but private data is going to still be private to the base class. You can't use that in a derived class. This is the message here. And this is really all I wanted you to see in this lecture. The big thing is to notice the syntax you use to do inheritance. And if you do this, the player class is going to be derived from person, and it will have a person part baked inside, and we can build on that foundation and, for example, put in our own member variables and do all kinds of crazy things. Public stuff from the base class are going to be inherited and usable from a derived class. We just saw that by setting up a bunch of setters that live in the public scope of the base class, and they were usable from the outside because they will be inherited as public in a derived class. So we can really call these methods and use them from the outside like we are doing here. But private data from the base class is not going to be accessible and usable from a derived class. And we saw that by setting up this piece of code in the constructor of player, this is going to give us a compiler error saying that first name and last name are private to the base class. We are going to stop here in this lecture. In the next one, we're going to learn about another kind of access specifier we have in C++, and that is protected. So go ahead and finish up here and meet me there.
Okay, so I think this is going to be the last chapter that we're going to do for today, because I am after trying to understand what the fuck I was doing with this, I'm fucking fried. Like, what are we at? So, protected members. Okay, so we're at the 23-hour, 22... Okay, hold on. Let me go C++ refer... no, what am I? Progress. That's the name of my text file. Okay, so we're going to do this. Chapter 18, and we're going to look at 23, 21. Dude, I spent two hours on 40 minutes of video. Holy shit. So we're going to do like that. Save that so that I know where I am. We'll call it protected members. Do like that. Okay. Because for some reason, I think it's kind of clicked now, but for some reason, when I was reading this and when I was calling P1 and all we were doing is printing out the data, right? For some reason, this running in the CPP file just wasn't it wasn't clicking. Like why is that going, huh? What's it doing there? Why is it doing that? And I think what was confusing me is just that I think this OStream operator is brand new and it hasn't been explained. I don't understand why we've started doing this. Cuz like it's one like if I'm happy to use it, but like I don't understand what it is. Like we've been doing what STDC out for this whole course so far, and then out of nowhere we're using an OStream address, and then it's operator. I don't this whole thing I don't understand. We know that this is outputting the name in the game. I don't know what this is. Yeah, what if I Google this? Operator. Because like my understanding, right, is with this is like a bit shift, right? We've done it many times with like STDC out, and then we have this, and then we have whatever other text that we put afterwards, whatever functions, whatever thing it is that we want to happen to print out essentially. And for some reason, I don't know what operator is. I don't know why I don't know what this is. And I might need to ask somebody to explain it to me. Yeah. So, but for now, I think we're gonna go ahead and call that good for today. I'm gonna hopefully get some clarification on that. Maybe write something down and explain it when I understand it better. But based on how this went, I'm kind of expecting this chapter to take a little bit longer than anticipated. So I'm gonna hop off now. I hope you guys have a good. Let me go ahead and do close. All right, go here. All right. Wow. I hope you guys had a good time hanging out with me. I've had a good time hanging out with you, even if I was confused and frustrated by some of the stuff. Always protect your member. Oh God. Yeah. I'll make sure to do that. But yeah. Even if I'm confused and frustrated, it is fun to learn. I like when this stuff clicks. It feels good when I'm like, oh, that makes sense. I understand it now. So yeah. I'm gonna try to get an explanation on that, and hopefully have some progress to report. I'll see if I can try to do some stuff with the Code Academy to see if I can maybe do like, I think it's Code Academy actually. I fucking hate that name. But I thought for years it was Code Academy. But yeah, we'll be back tomorrow. That is the intent. I want to keep grinding on this. I want to keep learning, keep understanding. I want to keep picking this stuff up because it's interesting, and for years I've never done it. I haven't done what I've set out to do, so I'm trying to do that now. Later, guys. Bye.